The Spicer system offers you the only complete system of drivetrain componentry: axle, driveline, transmission, and clutch. The Spicer system is more than hardware. It's specking, technical help, part support, and customized training, because knowledge is part of the package. Spicer training is state-of-the-art, and you decide what's best for you. A program at your local facility, a regional program at a Spicer System Center, or a class at our National Training Center. Our training gives you the competitive edge in specking, maintenance, and operation of vehicles with the Spicer system. Although many of the driveline components we see here are small, they play a big role in your truck's operation. Tom is our driveline specialist, and today we'll look at the different kinds of problems you may encounter with various driveline components. We'll also discuss what causes these problems and how they can be prevented.
That's right, Bob. First, we'll take a look at several types of U-joint failures, and then we'll progress to failed yokes and damaged drive shaft tubes. I'll wrap things up by taking a look at some failed splines and a failed shaft support bearing.
Sounds like a lot. What causes all these problems?
Driveline failures are most often caused by three things: poor lubrication, drive shaft overloading, or incorrect phasing and U-joint operating angles. First of all, lubrication procedures refer to more than just checking and changing the lube. I mean, it means using the correct lubricant, servicing the right lube points at the correct intervals or cycles, and using the correct methods. It's also important that you don't mix different lube types on your truck unless they are compatible.
I understand all that, but I have a few questions. How do I know what kind of lube I should be using with my equipment? And how often does it need to be changed?
I would check your Spicer lube chart. This should tell you the exact type of lube needed for a specific part. The chart also explains the lube cycles you should follow. For U-joints and slip yokes, you need to use an NLGI grade 1 or 2 grease with EP additives, or equivalent grease with an operating temperature range of plus 325 to minus 10 degrees Fahrenheit. All of the greases listed on Spicer's lube chart are compatible.
That's great. You also mentioned correct angles and phasing. Now, what do you mean by that?
To prevent early U-joint failure, driveline vibrations, and a number of other problems, it's important to remember three guidelines. All operating angles should be no greater than what's shown here, if at all possible. This chart shows the maximum operating angle allowed with different drive shaft RPMs. Now, angles should be equal or within the difference shown for the various drive shaft speeds. Be sure to consult with your truck manufacturer or your Spicer representative before altering driveline angles that exceed these limits. And finally, minimum operating angle should be 1/2 a degree. Now, standard phasing simply means that the inboard yoke gears must be in line with each end of the drive shaft. If they're out of phase, you'll experience driveline vibrations.
Okay, I understand all that. Is there anything else we need to cover?
Oh, just one more thing. Over-torquing the retaining straps or bolts of the drive shaft. Now, this means you need to properly torque the U-joint bolts to Spicer recommendations when installing a U-joint kit. Under or over-torquing bolts can lead to early cross failure.
So if I remember to follow those 3 points, I shouldn't run into the kinds of problems we're going to see, right?
Right. You can avoid most driveline failures by keeping a close eye on your truck and its performance.
Now, I know you have some examples of some driveline failures to show us. Why don't we take a look at them? Boy, these components sure look different from the ones we just saw.
Well, that's for sure. These component failures were all caused by one of the three items I mentioned before. Let's take a look at this U-joint first.
Okay. I see that the trunnions on this joint look like they've been worn pretty badly.
Well, they have. That's called spalling. The wear pattern that you see here is the result of the needle rollers sliding around the trunnion rather than rolling around it smoothly. This can be caused by excess torque load or a lubrication problem.
Yeah. Looks like spalling has occurred here in the bearing cup as well.
No, that's right. The constant sliding pressure of the needle in the bearing cup will cause this. The needle rollers make indentations in the trunnion and bearing surfaces, and small pieces of metal are chipped off bit by bit.
Now, I also heard of one-position surface spalling. How does this differ from what we've just been talking about?
Well, Bob, that type of spalling occurs when a needle roller becomes lodged between a trunnion outside diameter and the bearing cap inside diameter.
I see. And it appears that this U-joint has been worn out too, huh?
You're right. This is known as Bernelling. It occurs when the movement of rollers around the trunnion is severely restricted because of super tight bearing caps, excessively high angles or no angle at all, or an out-of-balance drive shaft. Now, Bernelling on the face of the trunnion is caused by a tight spline.
Let's take another look at another U-joint failure. This one seems to show a lot of wear on the end face of the cross.
That's caused by excess pressure and a scrubbing action between the thrust surfaces of the cross and the bearing cap. It's called galling, and in severe cases, the cross and the bearing cap may weld together.
That can't be very good for the system, can it?
It isn't. In fact, when this welding occurs, it can contaminate the lube, which leads to additional problems.
Will each of these failures caused by the errors we discussed earlier?
Oh, absolutely. I mean, incorrect lube procedures, over-torquing the attach bolts, or incorrect operating angles can all contribute to these problems, and many more that we'll see today.
Well, then let's keep going. What's next?
Well, we've still got a few more things to look at on U-joints. And let's take a look at that one over there.
Okay.
Now, you can see how the trunnion of this U-joint has become discolored and corroded. Notice how only one trunnion is bad. This is known as one trunnion failure, and it's caused when you don't thoroughly purge all four seals when lubricating the U-joint. Now, eventually, the bearings are burned away. If the joint is purged properly, you'll see lube out of all four seals.
Okay. Now, there's another cross failure. How could a break like that occur?
Well, this U-joint cross is broken completely. I mean, the most common cause of this failure is known as shock loading, or an abrupt, intense shock to your vehicle's drive shaft components. Now, shock loading can occur, for example, when you're spinning your tires and they suddenly take hold. Or it can happen when the driver pops the clutch. Now, as the truck lurches forward, it sends a severe shock through the entire driveline system.
Okay. Is that all we have in the area of U-joint failures?
That's it. Now let's take a look at a couple of damaged yokes. This is an excellent example of a sprung yoke. Now, you see how this has been bent out of shape because of overloading? In other words, applying too much torque to the driveline caused this yoke to bend. Now, you can check for a bent yoke with a Spicer go, no-go gauge and the alignment bar. Now, if the gauge fits into the yoke at any point, the hole is worn and the yoke should be replaced. The alignment bar should be able to pass easily through both cross holes if they are aligned correctly. Now, the wear and alignment of the yoke cross hole are very critical problems because they can lead to complete driveline failure.
What would cause the ears on this yoke to break?
This happens when a U-joint breaks as a result of shock loading. Now, that ends up destroying many of the attaching parts, like this yoke as well.
Well, if that's all we have for yoke failures, Tom, let's go on to the drive shaft tubing. This one looks a little bent.
Well, a bent or twisted tube like this one, well, that's the result of excessive torque or shock loading.
Okay. Now, that one over here is quite dented. Can that be caused by the same mistreatment?
Well, actually, these dents were caused by something striking the tube. I mean, this could have happened during installation or removal or running over something on the road. A good mechanic should always check tubes for dents or throw-in balance weights which may have been sheared off.
I guess the key here is being careful both in the shop and on the road, right?
That's right, Bob. A bent tube will cause an imbalance problem and lead to a number of driveline failures.
Now, here's a slip spline example. What happened to it?
Well, what we see here is a shaft spline that's seized. Well, improper lube procedures, particularly in the area of lube cycles, lead to this kind of problem. Now, this spline was not glide coated. Spicer's glide coat is a specialized coating that's applied to the tooth shaft spline to help prevent seizures like this.
So if I use the glide coat, do I still need to lube the splines?
Absolutely. Glide coat doesn't take the place of lube. It eliminates metal-to-metal contact and reduces slip forces.
Okay, have we covered everything now, Tom?
Not quite. The last component that we have here is a failed shaft support bearing. Now, these sealed bearings help support multiple section drive shafts. And because they're sealed, they never need lubrication. Now, if they don't fail simply because of old age, they fail because of torsional vibrations in the driveline that should have been investigated. That about wraps it up.
Thanks, Tom. Now, let's go someplace a little more comfortable, and you can give us a recap of what we've just talked about today. Okay, Tom, let's go over the main points you made, starting with U-joints.
Well, U-joints, trunnion diameters, ends and bearing cups are the main areas to check for wear. Now this may show up as brinelling, spalling, or end galling. Also, be sure to check the trunnions for signs of burning or breakage and avoid shock loads which may break the U-joint.
So the 5 major causes for any of these part failures are incorrect lube procedure and incorrect lube, incorrect operating angles and phasing, unbalanced drive shaft, and overloading the drive line.
Right. These are also the most common causes for failures to yokes, splines, and bearings. And don't forget the importance of a balanced drive shaft. An unbalanced drive shaft can cause torsional vibrations and damage any of the components in the Spicer system.
So if I encounter a driveline problem, I really need to check all of those parts.
Well, that's right, Bob. Just because you find one failure doesn't mean that that's all there is. If just one piece is damaged, it may have damaged others as well, or it may be the result of another, more serious problem.
In the long run, following a regular maintenance schedule and performing maintenance checks correctly should virtually eliminate the kind of driveline failures we've seen here.
And compared to the cost and the time it takes to fully repair or replace any drivetrain components, it's a worthwhile investment to do things right the first time. With the driveline playing such an important part in a truck's operation, it's worth the effort to keep it running smoothly.
Thanks for your help, Tom. I think we've covered some important points here today.
Spicer System Training for the competitive edge.